Most of you remember the Pythagorean Theorem, so maybe you'll think this is easy. Maybe you even remember the formula. But if not, if you've never seen it before, well, this will be your first introduction to it. It was proven by a mathematician named Pythagoras. That's why it's called the Pythagorean Theorem. And it has to do with finding the lengths of the sides of a specific type of triangle, which is a right triangle. So a right triangle, the word right means 90 degrees. So that's going to be a triangle that's got a 90-degree angle. And when these two sides of the triangle come together and make that 90 degree, we call it perpendicular. That makes what we call the legs. So these are the legs of the triangle, the ones that meet at 90 degrees. And we call those two legs A and B. We named them A and B. It does not matter who is A and who is B. It makes absolutely no difference. So those are the legs. The third side, this kind of diagonal side of the triangle, that is the hypotenuse. And you must label that one with the letter C because it is the longest side in the triangle. So it turns out, what Pythagoras found out is that if you take A squared and you add it to B squared, it's the same thing as C squared. So what this formula is good for is if you know two sides of the triangle, you can solve to find the third side. And you're either solving to find the hypotenuse or you're solving to find one of the legs. So it's a great little formula, but it only works for right triangles. And make sure that C is always the longest. That's your hypotenuse. So you might see problems like this. Find the missing side of the triangles below. And they should have a 90-degree angle labeled in there. So we can call 3A and we can call 4B, and then we'll call this missing side C. That's the side we're trying to find. So I know this formula is true. A squared plus B squared equals C squared. So A is 3, B is 4, and I'm going to try to figure out what C squared is. So 3 squared is 9. 4 squared is 16, and 9 plus 16 is 25. So that's C squared, but I don't want C squared, I want C. So how you solve, once you get to this point, how you break that down to make it just a C is you do the opposite, or the inverse. So the inverse of squaring is square rooting. So you would square root both sides. Normally we would put a plus and minus, but we're specifically talking about a length, so it can't be negative. So we're going to be looking at the principal square root, the positive one. And it's going to turn out that C is 5. So we have now found the missing side of the triangle. It's 5. This is what we call a 3, 4, 5 right triangle. Okay, so fairly simple to solve, and the numbers a lot of times will work out nicely. It's not a guarantee, but they usually work out pretty nice. All right, now this one we have a leg labeled 6, and then we have the hypotenuse 9. So I'll call those A and C. And what we're trying to find is this other leg, which is B. So again, I'll just start with my formula that I know. Pythagorean Theorem. We've got 6 squared plus B squared equals 9 squared. So 6 squared is 36. 9 squared is 81. To solve for B squared, I need to move the 36 over to the other side. So it's added, so I'm going to subtract it. So I'm going to subtract 36, and I'm going to get B squared equals 45. Move my paper up a little bit. And see, all these little calculations you can just do on any little calculator, like 81 minus 36. See, it's just 45. Okay, so now I have to square root to get that down to B, which means I have to square root the other side. So let's think about this. 45, let me come over on the side and just do a little factor tree. That's 5 times 9, and 9 is 3 times 3. Okay, so square root of 45 is like saying, changing the 45 into its prime factorization. So 3 times 3 times 5. And the reason I'm doing that is because right there is a pair. So I can pull out a 3, and what's going to be left behind is a 5. That is the exact answer. That is the exact length of side B, this leg. 3 square root of 5. If they wanted a decimal approximation, then you would go to a calculator. But actually doing all of this, the only time I really used a calculator was to do 81 minus 36. I didn't even use a calculator for the harder part, right? The factor tree I didn't need a calculator for. So that's how you would simplify the square root if you're doing the Pythagorean theorem. So exact answer versus if they want a decimal answer, they'll tell you like 1 decimal, 2 decimals. They'll probably tell you how to round it. A lot of times you'll end up with nice whole numbers though, but if not, it should be something that simplifies pretty nicely.